All right, guys, I got 3 examples for solving systems with elimination for you. So let's get started. Now, I'm not going to be the judge about whether or not this is a more convenient method. What I'm here to do is expose you to it, give you some practice, and then you can be the judge. So on the first one, I've got 2x minus y equals 4, and 7x plus 3y equals 27. So step one is to ask yourself, is it going to be easier to make the x's the same or the y's the same? I'm thinking the y's are going to be a lot easier because it's very simple to take like a one y term and make it look like the other y term. So if I were to multiply everybody on the top by 3, it would create a negative 3y here and a positive 3y here, and they would cancel each other out. So that's my first step. First step is to multiply by 3. So step 1, multiply the first equation by 3 to get the y's to be the same. So that creates a 6x minus 3y. Make sure you multiply both sides by that 3, okay? That equals 12. Yeah, and everybody in the second equation, nothing changes. So I'm just going to rewrite it as 7x plus 3y equals 27. Now here was the goal. The goal was to create a negative 3y and a positive 3y. The reason is because now if I add all the columns, the y terms completely cancel out. And I'm left with 13x on the left and 39 on the right. Yeah, all we got to do now is solve that very simple equation. Divide both sides by 13. All right. Let's see. 13 goes into 39, 13, 26, exactly 3 times. Yeah, and then from the previous video, we saw that, hey, I can plug that 3 into either of the first 2 equations. So plug that 3 into either of the originals. Doesn't matter which one. You're just kind of looking at like which one's going to be more convenient for me. I like the 2x minus y equals 4 because they're smaller numbers. Although you guys might like this one because there's no negatives to deal with. You be the judge. So I'm going to do 2x minus y equals 4. Instead of x, I'm going to plug in x equals 3. So instead of x, put a 3 in there. Now solve for y. 6 minus y equals 4. And shoot, you could guess and check on this one. 6 minus blank equals 4. The answer is 2. Here's how it would look if you worked it out. Subtract 6 from both sides. You get 0 minus y, so that's going to be negative y, equals 4 minus 6, it's negative 2. Make sure you divide both sides by a negative 1, otherwise it's going to give you a wrong answer there. Divide by negative 1, divide by negative 1. A positive clean y equals a positive 2. Okay, I've got my answer. X equals 3, y equals 2, make an ordered pair. And you're done. Let's try number 2. All right, so you got 2x plus 7y equals 1, 2x plus 20y equals positive 8. So if I got a positive 4x on the bottom and a 2x on top, I can multiply the top by negative 2 to create a negative 4x. All right, so I'm trying to stack a negative 4x with a positive 4x. And then everybody else gets moved through. So minus 14y on top. On the bottom, nothing changes because I don't need to multiply anything. And then take negative 2 times 1, which equals negative 2. The bottom is still 8. So yeah, notice that I just changed the top to match the x's on the bottom. Now when I add the columns, it's going to completely cancel out my x's. Negative 14y plus 20y would be positive 6y. And then negative 2 plus 8 is 6. Divide both sides by 6. Y equals 1. So now we plug y equals 1 into one of the originals. I'm going to pick 2x plus 7y equals 1. Smaller numbers are more manageable. So, take 2x plus 7y equals 1, and I'm going to replace the y with a 1. All right, now I have a simple Math 1a equation. Going to solve it. So this is 2x, 7 plus 7 equals 1. Subtract the 7 from both sides. 2x equals negative 6. Make sure you keep track of those negatives. Divide both sides by 2, and you get x equals negative 3. So your final answer is going to be the ordered pair, negative 3, comma, 1. Make sure the x goes left, the y goes right. All right, here's my last example. I got 4x plus 2y equals negative 14. And then I've got 3y plus 5x equals negative 17. I want the x's stacked with the x's and the y's stacked with the y's. I can flip these around using the commutative property if they're on the same side of the equation. So I'm going to do positive 5x plus 3y. All right, so this is the most important example because it really tells me who knows what they're doing and who's just kind of guessing. To get the number in front of x to be the same, you would need 20 to be the smallest number that divides 5 and the smallest number that divides 4. If you wanted the y's to be the same, though, 2 and 3 are divided by 6. 6 would be the smallest number that divides them both. So what I'm going to try to do is create a negative 6y slash positive 6y situation. So I've got some options. I'm going to multiply the top by negative 3, okay, which will make this a negative 6y. And I'll multiply the bottom by just a positive 2, because that would create a positive 6y. So create a negative 6y, positive 6y situation. All right, so negative 3 times 4x is negative 12x. Negative 3 times 2y is minus 6y. Negative 3 times negative 14 is a positive 42. Feel free to use a calculator to accelerate these calculations. Yeah. So take a 2 now times 5x, you get plus 10x. Take a 2 times 3y, you get positive 6y. And then double the negative 17, you get negative 34. Now, we've manipulated the situation so that when you add the columns, you're going to cancel one of the variables out. If you add negative 6y and positive 6y, it zeroes out the y. I got to add the other columns too. Negative 12x plus 10x is negative 2x. And then you got 42 plus negative 34. Remember, if you're taking a positive number and adding a negative, opposites subtract. So you take 42 minus 34, and then you take the sign of the bigger number. Get x by itself. All right. Last move, plug it into one of the originals. Seems like the top equation, I've been going with that every single time. Just to demonstrate that I can plug it into the bottom equation, let's go with 3y plus 5x equals negative 17. So I'm replacing the x with negative 4. The x is gone, times negative 4. So that gives me 3y negative 20 minus 20 equals negative 17. Solve the equation. Opposites subtract. Take the positive. All right, we've got our x coordinate, we've got our y coordinate. All right, guys, so that's elimination method. I hope these 3 examples were helpful and that you guys are moving forward on the assignment. No problems. Thanks for watching.